bias arrangement of a transistor. So first of all, what is bias? So as transistor is used as a oscillator, amplifier, etc., etc. For proper working of transistor, it is necessary to apply DC voltage across the junctions. So there are two junctions are formed. One junction is between emitter and base. That's why it is called as a emitter base junction. It is also called as a emitter junction. Now another junction is formed between collector and base of the transistor. That's why it is called as a collector base junction, and its another name is collector junction. Now the emitter base junction or emitter junction is always forward bias, and collector base junction or collector junction is reverse bias. So it is most important that the forward bias is applied to the emitter base junction and reverse bias is applied to the collector base junction for each configuration of transistor. Now first, biasing arrangement of NPN type transistor. Now in this, the emitter is N type and the base is P type. So to apply the forward bias across this emitter base junction, the positive terminal of battery VEE is connected to the base and the negative terminal of battery is connected to the emitter of the transistor. So therefore the emitter base junctions becomes forward bias. Now reverse bias is required for the collector junction. So the collector is N type and the base is P type. For that, the positive terminal of battery VCC is connected to the collector and the negative terminal of the battery is connected to the base. So here the base collector junction becomes reverse bias. Now similarly for the biasing arrangement of PNP transistor. Now here the emitter is P type and base is N type. So to apply the forward bias across the base emitter junction, the positive terminal of battery VEE is connected to the emitter and negative terminal of this battery is connected to the base. So therefore this emitter base junction becomes forward bias. Now to apply reverse bias across the collector base junction, the collector is P type and base is N type. So for that, the positive terminal of battery VCC is connected to the base and the negative terminal of the battery is connected to the collector. Therefore, the base collector junction becomes reverse bias. Now here emitter base voltage is represented by VEE. So this double DEE is represented, that means there is no change in voltage. That means whatever voltage, forward voltage applied to this junction is fixed. Now it is also represented by VBE. That means the voltage applied between base and emitter. It is also denoted by VE. That means the voltage applied to this junction is varied. Or similarly, the base collector voltage is represented by VCC. So double C indicates that there is no change in voltage. That means it is fixed. Now it is also represented by VBC. That means the voltage between applied voltage between base and collector. Now it is also denoted by VC. That means the collector voltage may be varied.